Hi everyone, welcome back to another video lesson for Unit 11. So today you learn how to multiply radicals. On the previous lesson you learned how to add and subtract radicals. And now this lesson is a little bit different because now we're multiplying. Okay, so notice the instructions here. We multiply outside with outside, which means coefficients. You multiply coefficients together and then you multiply what's inside of the radicals, meaning the radicands. So for example, in this case, 4 is outside and 5 is outside. So then you multiply 4 times 5. And then you multiply what's inside. In this case, you have a 5 inside of the radical. And then you have a 10 inside of the radical. Okay, so that's what it's saying. When you multiply outside times outside, which is 4 times 5, that's equal to 20. And then when you multiply 5 times 10, that gives you a 50. Okay, but then don't forget this when you try to simplify. So I'm going to simplify this 50 by decomposing it as 2 times the square root of 2 times 25. But then 25 is the same as 5 times 5, which means we can take out a 5. So I'm going to keep going in this direction. So there's a 20 waiting outside, which is 4 times 5. And then we have a 5 coming out. And then this 2 that's by itself stays inside. Okay, I'm going to keep going in this direction. So then 20 times 5 is 100. And the 2 stays inside, so this is 100 square root of 2. So that's the product of those two radical those two radicals. Okay. All right. Number one, same idea. You're going to distribute just like you do with x, right? So for this one, when I multiply, I only have, this is implied to have a 1, so I'm multiplying 1 times 2, which is outside times outside. So 1 times 2 is 2, and then just tag or keep the square root of 6 next to it. Okay, and then when I multiply positive times negative, that becomes negative 1 times 3, that's negative 3, right? So 3, and then keep the square root of 6. Now they have the same radicand, meaning they have the same square root, so that means these are like terms. So then what we're doing is we're just combining. Let me see here. Actually, no, this is not true. What I need to do is 6 times 6, which is this. But then again, we have 2 6's. So I hope you realize that the 6 comes out of the radical. So this is 2 square root of 6 minus 3 times 6. Well, 3 times 6 is negative 18, right? So these two terms, when you multiply them together, these two numbers, when you multiply them together, they become negative 18. So what I'm going to do is I'm going to rearrange so that this is first and then the radical is second. So then this is negative 18 plus 2 square root of 6. And this cannot be simplified any further. So that's the answer to this problem. Okay, let's go on to the next example. So on the next example, we have the cube root. So when I multiply cube root of 3 times square root of cube root of 9, this becomes the cube root of 27. And I hope you remember this one from the previous lesson. And then when I multiply cube root of 3 times, let's see, so this will be 4. So keep that 4. This has a coefficient of 1 implied. And then cube root of 3 times 21, that's 63. Then 27, on the lesson from yesterday, 27 is a perfect cube because it's 3 times 3 times 3, right? So then this becomes just 3. Now this one we can try to simplify it. So let's say 3 times 21 is 63, and 21 is 3 times 7. So then notice that we have 2 3's and 1 7. So those are prime numbers, which means we can't really take anything out because we need 3 of them to be able to take one out. So then this stays as 3 minus 4 times the cube root of 63. And that's the answer to this problem. Okay, but still try to simplify, see if you can take something out of the radical. All right, for the next example. So for this example, what I'm going to do is this is just again like when you multiply polynomials or binomials together. But for this example, we have radicals. So I'm going to use FOIL for this example, meaning multiply 2 times 4, that gives us 8. 2 times negative square root of 6, that's negative 2 square root of 6. And then square root of 6 times 4, that's plus, let's see, so 4 square root of 6. And then square root of 6 times square root of 6, that's square root of 36, but this is negative, so this becomes, we know the square root of 36 is 6, so that becomes minus 6, right? Okay, oh, maybe I should, let me just write it down so that I don't confuse, so I rewrote it. So this is 6 times 6, which is 36. But then again, we know that the square root of 36 is 6, so then this becomes minus 6. So notice I have positive 8 and negative 6 combined to positive 2. Negative 2 square root of 6 plus 4 square root of 6, that's plus 2 square root of 6. And this is the simplest answer for this problem. We are done with this example, okay? All right, so that's example number 3. Example number 4. Now, in this case, we have, this is a mess, but just don't forget outside times outside and inside times inside. So then 4 times 3, that's 12, square root of 5 times 5, that's square root of 25. And then next we have 4 times negative 4, that's negative 16. 5 times 3, the radicals together, so 5 times 3 is 15, square root of 15 here, okay? Then 3 times, 3 square root of 3 times 3 square root of 5, 3 times 3 is 9, and square root of 3 times 5 is square root of 15. And next 3 times negative 4, that's negative 12, and 3 times 3, that's the square root of 9. Again, this is 5, right, because square root of 25 is 5, and this one is 3 because the square root of 9 is 3. So then this becomes 12 times 5, negative 16 square root of 15 plus 15, 9 square root of 15, that's plus, no, minus actually, minus 9 minus, 60 minus 9 would be, because the 16 is negative, so negative 16 plus 9 is negative 7 square root of 15. But then this becomes negative 12 times 3. Right, so then this is 12 times 5, which is 60, minus 7 square root of 15, and this becomes minus 36. When we combine 60 minus 36, that leaves us with the 24. So this is 24 minus 7 square root of 15, and this is the simplest answer for this problem. We're done with this one, okay? Next example. Notice we have the square, so that means we have 2 of those binomials. So 3 square root of 2 minus square root of 3, that's 1. And the other is also another copy of this, so 3 square root of 2 minus the square root of 3. Now let's multiply. So 3 times 3, that's 9. Square root of 2 times square root of 2, that's square root of 4. So that's this times this, these 2 terms together. And this one times this one, 3 times square root of 2 times square root of 3. So that's minus 3 square root of 6, because 2 times 3 is 6, right? Then the inner, negative square root of 3 times 3 square root of 3, that's negative, that's implied to be negative 1, so that becomes negative 3. And let's see, 3 times 2 is 6, so square root of 6. And then next we have negative times negative is positive, and 3 times 3 is 9, so this is square root of 9. Now this one, as we said before, square root of 4 is 2, so then this becomes 9 times 2. And then let's see, so this is negative square root of 6 minus 3 square root of 6. That's just combine them together because they're like terms. So negative 6 square root of 6. And this becomes 3, right? So then plus 3. But we know 9 times 2 is 18. And when we combine 18 and 3, that becomes a 21. So 21 minus square root of 6, 6 square root of 6. Now notice, you might think, well, 6 is not prime. But the only factors of 6 are 2 and 3. So you only have 1, 2, and 1, 3. We can't take anything out of the radical because we got to have 2 of those numbers to be able to take one out. So therefore, this is our final answer for this problem. So I hope this wasn't too bad. All right, thank you for watching. I'll see you in the classroom. Bye-bye.